Welcome back. In this session, we'll explore the critical interaction between retrieval and generation, the two pillars of retrieval-augmented generation RAG. Understanding how these components work together is essential for appreciating the power of RAG in enhancing generative AI models. By the end of this talk, you'll understand how retrieval feeds into generation, how the synergy improves accuracy, and how this process addresses the limitations of traditional generative models. Let's dive in. Let's start with retrieval. Imagine you're asking a question to an AI model. Instead of generating an answer solely from its pre-trained knowledge, the model first retrieves relevant documents, snippets, or data points from external databases, APIs, or indexed knowledge bases. This retrieval step acts like a librarian searching for the most relevant books or articles before answering your query. Techniques like BM25, dense retrieval, using face or DPR, or hybrid models are used to fetch information that closely matches the query. Retrieval is crucial because it anchors the generative process in factual external knowledge, reducing the risk of hallucination, a common issue where generative models produce plausible but incorrect information. Generation, synthesizing information. Once the retrieval step is complete, the generative model takes over. This component is typically a large language model, LLM, like GPT-4 or BERT, which processes the retrieved documents and synthesizes them into coherent, contextually relevant responses. Think of it as reading multiple articles on a topic and summarizing the key points into a single, cohesive explanation. The generative model uses the context provided by the retrieved documents to produce accurate, grounded outputs that directly answer the user's question. Without retrieval, the generative model might only draw from its pre-existing knowledge, which could be outdated or incomplete. Retrieval ensures that the generative component remains informed by the latest and most relevant data. The feedback loop, continuous improvement. A key feature of RAG is the feedback loop between retrieval and generation. If the initial retrieval doesn't provide sufficient information, the model can refine the query and perform another round of document retrieval. This iterative process allows for more nuanced and comprehensive responses. For example, if a user asks about the latest advancements in quantum computing, the model might retrieve general articles first. If those articles lack detail, the system can automatically re-query for more specific publications, enriching the generative process with deeper insights. Parallel processing, speed, and efficiency. One of the strengths of RAG is the parallel processing of retrieval and generation. While documents are being retrieved, the generative model can begin pre-processing the query, minimizing latency. This parallel approach ensures fast, responsive outputs, even for complex or multi-step queries. In high-stakes environments like healthcare or finance, this efficiency can make a critical difference, allowing AI to provide timely, accurate information when it matters most. Real-world example, medical diagnosis assistance. Consider a medical assistant AI tasked with providing diagnostic recommendations. A user inputs symptoms, and the retrieval component fetches recent medical papers and case studies. The generative model then synthesizes this information to suggest potential diagnoses or treatment options, grounding its response in the latest medical research. Without retrieval, the AI might base its suggestions on outdated medical literature. The combination of retrieval and generation ensures the model remains up-to-date and accurate. Addressing challenges. While retrieval-generation interaction offers numerous benefits, it does come with challenges. One issue is ensuring that retrieved documents are relevant and of high quality. Poor quality or irrelevant documents can mislead the generative model, resulting in inaccurate outputs. To mitigate this, RAG systems often implement filtering mechanisms, confidence scoring, and multi-step verification to ensure that retrieved data aligns closely with the query. Another challenge is latency. Although parallel processing reduces wait times, the retrieval step can still introduce slight delays. However, as retrieval algorithms continue to evolve, this latency is expected to decrease significantly. The future of retrieval and generation interaction. Looking ahead, we can expect even tighter integration between retrieval and generation. Future RAG architectures may incorporate more advanced forms of vector search, allowing for even more precise document matching. Additionally, Generative models may develop the capability to prioritize certain types of documents during retrieval, enhancing overall performance. As AI continues to evolve, the interaction between retrieval and generation will remain at the forefront, driving the development of more accurate, reliable, and context-aware systems. In summary, the interaction between retrieval and generation lies at the heart of RAG, enabling AI models to produce accurate, dynamic, and fact-based outputs. By anchoring generative capabilities in real-time knowledge retrieval, RAG represents a significant step forward in AI development. Thank you for joining this session. In the next module, we'll explore practical steps to build and fine-tune RAG models for real-world applications. I look forward to seeing you there.